In this video, we are going to look at a very intuitive class of operators in C called relational operators. Relational operators simply compare two quantities, and there's not all that much magic to them. You can simply look at them and understand what they do, with the exception of these two. These two are a little bit less intuitive, so we have to talk about them in a slightly more detail. I mean, these four you already know. There's no point in trying to explain them. Here, we are trying to assess whether two quantities are equal to each other. When you just use one equal sign, what you'll have is an assignment where the RHS is put, the value of the RHS is put in the variable box that is declared on the left-hand side. When you're trying to ask, not tell the computer whether two values are equal, you use two equal signs in a row. This is asking the question, is the left-hand side equal to the right-hand side? Its complement is this expression, or sorry, this operator, which is the not equal to operator. This is exclamation followed by an equal sign. And this means we are asking the question, are these two quantities not equal? Whenever this operator operates and the condition is satisfied, it returns a value of 1. And if it is not satisfied, then it returns a value of 0. This is true for all of these operators. If any of these conditions are satisfied when this operator is used, the expression on both sides together with the operator resolves to 1. And if not, it resolves to 0. And these operators work on int, char, float, double, you name it, all possible data types. The result, as I already told you, is either 0 or 1, depending on whether the condition is satisfied or not. Let's take a look at some examples. Here we can see when 3 is greater than 2, this is tested. The result is 1 because 3 is greater than 2. When you ask the question, is 3 greater than 3? The answer is no, it is not greater than. If you had asked, is it greater than or equal to 3? The result would have been 1. You can ask if z is greater than a, which is going to be true because the ASCII value of small z is larger than the ASCII value of small a. When you ask if 2 is equal to 3, you get the result 0. They are not equal. When you ask if a is less than or equal to 65, you get 1 because a has exactly the ASCII value of 65, etc. So you can see that there's all kinds of combinations of types that can be used as long as they are interoperable in terms of the arithmetic operators that are being applied to them. You can do these tests. This you should not do. Why exactly? We'll see that in the next week when we understand the differences between how integers are represented in ints and how floats are represented in float. Well, how decimals are represented in floats. And so this sort of comparison is always surprising and you shouldn't try it. Let's take a look at another use of relational operators. Here, the problem statement is to input 3 positive integers and print the count of inputs that are even and odd. Now, when we look at conditionals next week, you will see that this sort of thing can be done quite easily using if-then-else logic. But let's assume that we don't know about if-then-else. How could we do this? So here is a simple expression that allows you to calculate this. You can say, I want to see if the first one is even. If it is even, then a modulus 2 will be exactly equal to 0. If b is even, b modulus 2 is going to be equal to 0. If c modulus 2 equals 0, that means that c is even. So if any of them are even, they will contribute 1 to this overall bigger expression. If all of them are even, we'll get 3. If none of them are even, we'll get 0. So you can just print out C even as the number of even numbers that were input, and you can print 3 minus that number as the number of odd values that are outputted. So this is a nice way of trying to combine relational and arithmetic operators to do something interesting. This table shows you the precedence of relational operators with respect to the unary operators that we've seen already and the arithmetic operators that we've seen already. You will notice that they have much lower precedence than both unary and arithmetic operators. In fact, they only have higher precedence than the assignment operator, which is just the equal to sign, which assigns the value in the RHS to the variable in the LHS. The associativity for the conditional operators is the traditional left to right. The only operators that have associativity from right to left are the unary operators up top and the assignment operators that you can see down below. We will talk about assignment operators separately. In this table, I just wanted to show you that the precedence of the relational operators is lower, such that they are evaluated after arithmetic quantities have been computed. Please keep this in mind when we look at some of these problems in the coming week.